All right, I'm David Hoppe. I worked with Rob for a while back. A couple years ago, 2012 was it? And so we worked on the same team, and that's pretty good. I saw that he was booting up so fast back into local variables. I said, hey Rob, I can do a session for you. And so here I am. Work at a company called Parsing. They're in town here, not too far away. And worked at a few other places since I worked with Rob there too. So it's about time. Okay, that's the title of the talk. It's time. So what? You just say datetime.now and you got time. Who cares? So why is it enough to give a talk on it? Well, that's what I was kind of thinking too a while back. These are some images of a project I was working on a while back. These are GPS trackers, various iterations. Iterative development in hardware can get expensive. Each board costs $200. So you get a stack of them, and then you have to solder them together. Anyway, so those are GPS trackers. I was working on GPS trackers, writing the software for them after I finally got one to work in the hardwares. And everything was going great. We wanted to get the time from the GPS. GPS spits out what time it is in its string of goo that it tells you about when you get a position. And so awesome. I got that translated. It's coming through my debug stream serial port. And then I send it up to the server. And then I compare the GPS time with the server time. And I find out that my reports are from 14 seconds in the future. And I'm like, wow, I'm good. So I can tell whether GPS is going to be in 14 seconds. Well, that's what started this whole journey for me. So after finding out more than I really wanted to know and becoming astounded at the befuddling aspects of time, I decided I would not keep this knowledge to myself. I would share it so that everybody else would be confused also. Alright, so we're going to look at that a little bit. So what is time? So I'm going to ask for some participation. Just shout out and answer if you have anything particular. Anybody have just anyone answer for what is time? Yeah.
An inevitable march towards death.
Well, Texas comes first, but that's beyond us now, so we get another year.
What aspect of time? I mean, time is a unit of measurement?
Anything you want to say about time? It's just an opportunity.
The fourth dimension of reality.
Fourth dimension of reality.
Okay.
What'd you say?
With which we can measure the changes that's happening around.
Okay, so with which we can measure changes happening around us. I'm just repeating so everybody else can hear. And what'd you say? Yeah.
I thought, I mean, what I really think it is it's a measurement, it's just a measurement of entropy, basically. I mean, as things progress further and further along, you have more and more entropy. So it's a rate of entropy, I suppose.
Okay, a measurement of entropy as things progress further and further along, you have more entropy. So measuring the progression of that. Cool.
Okay.
Yes?
The orbit around the sun.
The orbit around the sun.
Yep.
Okay. Now
Calendar time.
calendar time. Okay, good.
24-hour time.
24-hour time. Okay, good. So I found an interesting quote from St. Augustine in Book 11 of St. Augustine's Confessions. He ruminates on the nature of time, asking, what then is time? If nobody asks me, then I know. When I'm asked, I do not know. Which, basically, when I ask what is time, the room falls silent. Same way. Well, I thought that was a really neat way of saying it. What is time? I know if nobody asks me, but then you ask me to explain it. I don't know. So, all right. So, what is a day? So we kind of touched on the Earth orbiting around the sun. That's a different measure, but what's a day?
The Earth orbiting on its axis.
Orbit
spinning.
Sunrise to sunset.
In its
Okay.
own axis, rotation of the Earth and sun.
So the Earth's spinning around on its axis one time.
One.
Okay. That's a good definition, and we're gonna explore a little bit, John. Are you John?
Yep. I'm talking. Well, I have two questions about that. One, what is a day here on Earth? If it's just one rotation around a planetary object, then there's also a day on Mercury, a day on Jupiter, a day anywhere else.
Yep.
Furthermore, you realize that as the days, every day that you are living is getting a little bit longer every day.
Yeah?
Because the rotation of the Earth is slowing down.
Yep.
So is a day constant,
Oh, that's a good question.
or
Yeah. We call that foreshadowing.
In context, then you're just talking about Earth and Earth Day. Is that correct?
Yes. For our context right now, yes. You can have different days, Mars days, Earth days, Pluto days. Oh, Pluto's not a planet anymore, sorry. Okay, so what is an hour?
60 minutes.
60 minutes. We don't know
We
what
have-
it is yet, though.
Yeah.
We only know what a day
It's
is.
the 24th of a day.
Fraction of the day.
1/24 of a day.
Okay, cool. So that's pretty easy to define. We define the day pretty easy too. That's gonna get more complicated. What is a minute?
60.
The 60th of an hour. What is a second?
60th of a minute.
the amount of, was it 380,000 kilometers, or how far light travels? If light travels in the vacuum 3,800 meters or kilometers, that's 1 second. It travels this far. That's how I would define a second.
Okay.
And according to the SI system of measurements, a second is defined by a certain wavelength of hydrogen.
Difference, clocks.
Before, I forgot to write down the date. Around 1970 something, a second was 1/86,400th of a day. So just do the math. What is a day, an hour, minute, a second, go on division. But now it is based on 9 billion transitions of a cesium-133 atom. Yeah, so that's the official SI definition. 9 billion some odd transitions of a cesium atom. So that's the official definition of what is a second. So we're going to explore how we got to that a little bit. And we're going to start with what is a day. So I'm going to need 3 volunteers. 2 are going to come up here and move around a little bit, so you get comfortable with that. And 1's going to stand in the corner. And everybody must be able to count. So
I'm out, I can't count.
Rob! You're a volunteer. All right. We're looking for 2 more. All right, cool, awesome, thanks guys. All right, so who wants to stand in the back corner?
Okay.
Okay, you're a star. And one of you gets to be the sun, and one of you gets to be the earth. Sort that out amongst yourselves.
Do the sun.
All right, Rob, you're going to orbit around the sun, spinning around, making days. Now stop. All right, point at the sun with your nose. And sun, you're going to count how many times Rob points at you.
Wait.
So-
If you guys, can we have them move over here so it's on camera? There we go.
Thanks, cameraman.
No problem.
And star, you're going to count how many times Rob's back points at you, because otherwise the references might get funny, and if you start with his nose, you count like halves. So, Rob, spin around, making sure it's quite a few times. And the rest of the stars can count also if you'd like.
You know, I do this with my kid at home. And then we fall on the ground.
Faster.
All right, that's good.
This is why I was the sun. I did not think this should occur.
So it's been 1 Rob year now. How many days did you count?
I counted 5 days.
How many days did you count?
6.
Oh. So, according to you, it was far off. You counted 6 days, and you counted 5 days. Because as he was rotating, he also went around once, which took up one of his rotations from his perspective. So, we have a difference in how we can count days. Now, historically, days came from the sun coming up and going down. So, a day, what we know as a day, is a solar day. So, from the perspective of the sun, that's a solar day. So we can get a little bit closer on the definition of a day. So it's the time from when the Earth is pointing at the sun, as like a certain part of the Earth is pointing at the sun, until the next time it's pointing at the sun. And then from Alpha Centauri over there, we have sidereal time. So the time it takes for the Earth, a point on the Earth, to spin around and point at the same celestial point, like an infinitely far away. So it's spinning around within the universe to be the same. Of course, it's never going to be the same because everything's all moving in crazy ways. So that's just a difference between sidereal time and solar time.
So which one's longer?
So sidereal time is shorter because he had 6 days, and solar time is longer because if the Earth was spinning the opposite way as it was orbiting, then solar time would be longer and sidereal time would be shorter, but it's spinning the same way as it's going around in orbit. So it takes longer to see the sun again than it takes to spin around and see the sun. So in the year, we have 365-ish solar days and 366 sidereal days. And then that's why the part of why the stars appear to move and stuff like that. So that's one of the interesting things I found as I was going through all this is what is a day? And as John alluded to, days aren't really as long as they used to be. Wait, they're longer than they used to be because
They're slows down.
they're slow down. So that is where the classic definition of a day is and where all these measurements kind of come from. So classically, I mean, you didn't have clocks, you had sticks in the ground being sundials. Before that even, it was just sun's up in the sky, sun's down, okay. So you count days with that, and then you count the seasons. So, thank you very much. Thank you, Sun, Star, and Rob. No, planet.
Not that big.
A very small planet. Alright, so that gets us to how is time measured. So it starts with just days. You can see the sun, you can't see the sun. And then the next time you can see the sun is another day. So then you start to get like sundials, and then mechanical clocks, and then electronic clocks, and digital wristwatches, which if you read Douglas Adams, he makes a big deal about digital wristwatches. They must have been entertaining. But that's where things start getting weird because the clocks started getting accurate enough that, so the clock has a pendulum or however they regulate the clock. This clock gets accurate enough that they can start discovering that the clock time isn't always in sync with solar time. Okay? So the hours aren't uniform between the seasons. And so to calibrate a clock against a sundial, you have this kind of graph, so that in January through March, your clock or watch is faster, and then it dips in through April, May, so the watch is slower than the sundial. June through August. This is the equation of time. So it's a yearly thing. The Earth, solar time varies against mechanical time, watch time or clock time. So this is caused by the rotation on the Earth, a 23-degree tilt of the axis that gives us seasons. It also gives us wacky time. So it's another interesting that I found while trying to figure out why my GPS records for 14 seconds in the future. And this is part of it. So part of the reason is the way they keep this in sync with the mechanical time.
Is that graph symmetrical about the equinox there in June, or was it June 21st? Where it crosses the,
It doesn't.
oh, right there, yeah, it looks symmetrical about that one point.
It
Inverse symmetry.
could be. And then December 21st would be about here, so it kind of seems like that could be.
The raising of the graph for.
Peaks are different.
Yeah, but this is not as deep as this is high. So, and I don't know the scales and stuff on this. I thought this was interesting. I looked into it a ton, but it's pretty cool to know. And also, in the southern hemisphere, sundials, first of all, they go backwards. And second of all, because of this, they're more inaccurate than northern hemisphere sundials. So you don't see very many sundials in the southern hemisphere. So which one is right? So, does anybody know what time it is right now?
Apparently not.
No. It's 8:50 or 6:51 or whatever. But there is a number of time standards. So you got atomic time, universal time, which is broken up into UT0 and UT1, coordinated universal time, which is UTC, dynamical time, which is one of my favorites because the word's cool, geocentric coordinated time, barycentric coordinated time, and sidereal time. So I have to look at my notes to make sure I get this all straight because there are so many. Oh, bad. Uh-oh. Here we go. Sorry. So, atomic time, TAI. The International Atomic Time Scale. None of these abbreviations are, well, universal time is right, but the rest are in funny words because they're all actually French. We'll talk about the French people again in a little bit. So, atomic time, International Atomic Time Scale, is based on a large number, that's in quotes because that's really what it says on the site that I got it from, of atomic clocks. So, various entities keep atomic clocks, and TAI is the consensus of those clocks. So there's people whose job it is to keep the clock running and synchronize with the other clock keepers. It sounds like either a very boring or very interesting job. Universal time is counted from 0 hours at midnight, with the unit of duration being the mean solar day. So the average solar day, adjusted to be as uniform as possible despite variations in the Earth's rotation. So, go back to this graph. They average out this, not the mathematical computation of this, which I forgot to mention came from Ptolemy, his research in ancient Egypt. He actually had this figured out for a lot of other stuff. So ancient Egypt, they had this kind of figured out. That's pretty cool. So, I know it's quick because I want to universal time is the average time throughout the year, averaging out the faster and slower bits of solar time throughout the year into universal time. And UT0 and UT1 are related to universal time. Coordinated universal time, which is abbreviated UTC, is what most of us set our clocks by. So coordinated universal time, if you see those atomic clocks that automatically figure out what time it is, they are based off from that. And coordinated universal time differs from TAI by an integral number of seconds. So either 1, 2, 3, 4, any integer number. And UTC is kept within 0.9 seconds of UT through the introduction of leap seconds. So when UTC and UT start drifting apart, as they will, because universal time is following solar time, from midnight to midnight solar, and coordinated universal time is following the cesium atoms bouncing around. So there's too many seconds in a day, and like a fraction of a second too many every day. And so every once in a while, they have to insert a leap second into coordinated universal time so that we don't drift apart. Otherwise, in about 1 billion years, midnight would be having the sun over top of us. And I gotta scroll down to the next one. UTC has replaced GMT as a standard. There used to be GMT, which was like standard time, but UTC redefined that, and GMT got downgraded to just being a time zone. So GMT is plus minus 0 time zone in around.
The Greenwich Mean Time?
Yes. So that used to be the standard, but the scientists all got together and had a big meeting, and then had another big meeting, and then had a bunch more, and made UTC. Because we didn't have enough abbreviations for time. So these are the scientific standards for time, some of them. And now we're going to talk about leap seconds. We are very fortunate to have a leap second coming up very soon. It's going to be June. So this is a bulletin from the IERS, which is the International Earth Rotation Reference Systems Service. So there's a service that rotates the Earth. In case you're wondering, this is their, oh,
Wow. Is that a web service?
it's the International Earth Rotation Service. Well, I think it's a lot like the weather service. They don't make the weather; they just measure it and try and get it. So, this is a bulletin, the latest bulletin. It came from Paris on the 5th of January, 2015. This is bulletin C49. A positive leap second will be introduced. So far, all the leap seconds have been positive, so there is the possibility of a negative leap second. And there's an FTP site that you can pull these bulletins off from. And there's another bulletin suitable for automatic consumption. So if you want to write software to automatically do this, it's really good, because otherwise you might miss a leap second. So on June 30, 2015, at 23 hours, 59 minutes, and 59 seconds, the next time will be June 30, 23 hours, 59 minutes, and 60 seconds. And then it will be July 1st, 000. So we're going to go, the seconds are going to go, instead of 59.0, like normal, it's going to be 59.60.0. So you watch your watch on the seconds and see if it goes to 60 on it. My imagination says you're going to have to fix your watch to sync back up with time. Otherwise it's going to be a second. So what's all this deal with leap seconds? I mean, I guess they couldn't sync up the Earth with the cesium atoms, and so they got screwed up. But why can't they just have them like every 4 years, like leap days? Leap days, yeah. Well, it turns out. Oh, also, this is the equation to figure out why UTC and TAI are off. So, from the last leap second was July 1st, 2012. There's only 2 dates that are valid to have leap seconds. It's July 1st and sometime in December. They do that, I don't know why, but that's what they pick. So from July 1st to 2012 to July 1st, 2015, the difference between UTC and TAI, which we all know is Universal Coordinate Time and atomic time, is 35 seconds. So UTC is 35 seconds ahead of TAI. And after July 1st, 2015, until further notice, it's going to be 36 seconds difference. And that, it turns out, is why my reports were 14 seconds in the future. They were actually a few seconds in the past. And when you do the math, everything turned out to be just fine. So that turns out to be the answer to my conundrum that started this off. So the GPS module was reading TAI because the GPS time is not offset from UTC. So they take TAI time. And so it was reporting that, where computers are typically UTC time. So they sync up to NTP and stuff like that. And the difference in that was my 14 seconds in the future. Leap seconds, and why aren't they uniform? Okay. This is a graph of the rotation of the Earth from 1973 on that end to 2008. The speed of the rotation of the Earth. As you can see, we're going to get down to 0 rotational degrees every day in a couple years. So the Earth's going to stop. Wow, no, because this is just how many milliseconds using this as a baseline. So in 1970, our days were approximately 3 milliseconds shorter than what they are now. So this is a solar day. Length of day minus 8400 seconds, or 86,400 seconds. So seconds, the average day was about 3 milliseconds shorter than what it is now. So since 1970, we've lost 3 milliseconds, or gained. The Earth has slowed down to 23 milliseconds. But you can see that it's not like just slowing down. It goes, faster and slower and faster and slower. It's following this kind of thing. So this is part of what the International Earth Rotation Service does. They measure the rotation of the Earth and then tell us when it's time to introduce a leap second. So this is all interesting and stuff, but how does it really affect me? Well, first of all, depending on where you're getting your time from, you might have to know that you have to adjust it to get to whatever time standard you want to store it in. So, like I was pulling it from the GPS, which was using TAI, and comparing it to UTC in my computer system. And that had me hooked up a little bit. That could have been really bad, because what if I'm in court testifying that yes, the tracker was there at that time, and yes, it went to there at that time, and they say, well, what time standard was it? And I'm like, well, I don't know. So then a lawyer will be all over me about that, and if I say, well, I got it from GPS, that's in TA time, I converted it to UTC time, this is the equation I use, this is the bulletin from the AIRS, and blah, 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 then the lawyer goes and hides in a corner and whimpers, and I win my case. But also, there's a lot of people that buy server time by the unit of time. So if you're using Amazon servers, do you get billed for that leap second, or do you get a freebie? If you're buying $20,000 worth of Amazon servers every hour, that 3 second could be worth a couple chunk of change, or you could get billed for it. I don't know. How else might that affect you? You got leap days, and that can really screw things up. We'll see that in a little bit. And you got to keep your time in sync. We're going to talk about that next. So keeping your time in sync. In the really olden days, they had town crier, every hour, say it's 3 o'clock and the ice is freezing and stuff like that. Tell everybody what time it was. That was kind of a local time sync so that everybody could set their grandfather clock to be the same time. But about the time of trains and telegraphs, they had to come up with a way to synchronize time so that the train could be on time. Because, you know, it gets into the city, we're going to be here at such and such time. Well, how do you know that this time is the same time in that city? You send a letter and tell them what time it is, but I guess they're so they use the telegraph to synchronize time. They put the watch on the train, take the train to the next place and synchronize time that way. But eventually, we got to the point where we're using a special radio station to synchronize time. So like those atomic clocks and such, there's several radio stations around the world. One of the big ones is Boulder, Colorado. This radio station has been operating continuously since 1920. WWV. It's now called WWVH and WWVB. VH is in Hawaii, VB is in Boulder, Colorado, but WWVB has been operating continuously since 1920. It's the oldest operating station in the United States. Thought that was kind of interesting. It transmits the time continuously on 2.5, 5, 10, 15, and 20 megahertz. So when you tune into any of those, and that is the time. So back in pre-internet ages, so ancient history, that was how you synchronize time. And this is also how you can tune your radio transmitter. If you don't have a accurate time base for your radio, you can tune up to this, calibrate your dial based on that, and then do some math to do a lot of other tuning and stuff like that. So this is a card from a communications report. They call these QSL cards. Ham radio people love these things. But this is a report from 1940 that someone was able to hear the station at a certain place. But if you're building a radio, and even like if you have a modern radio and you want to see if it's calibrated, you tune up to 5 megahertz. And if a dial agrees with it being 5 megahertz, then it's good. If it doesn't, you probably have a little work to do. I have a sample of the audio from that. I was going to play it on my radio, but the reception isn't good enough in here. So we're going to see. No, not working. A minute, it's going to play a bit of a more interesting part. You can hear the ticks, those are second ticks. Alright, so that is how atomic clocks work. So there was a beep. I don't know how good you guys can hear that or not, but at a certain time there's a tone. So there's also some digital encoding there. One of the cool things about WWV is that they have a flag for daylight savings time. Not all clocks honor that flag, so this is one of our first time bugs. I was doing work at a high school several years ago, when daylight savings changed. So I don't know if that was before daylight savings time was around here now, but they changed daylight savings time from a smaller window to a larger window. And so the school found out they had to replace all their clocks because all their clocks were atomic clocks. And the time change was hard-coded in the clock. It didn't honor the daylight savings time flag. So they had to go through the school and replace all their clocks. Actually, I don't think it cost them anything because I think they got the clock manufacturer warranty. So, you gotta watch those clocks. They're cheap, and they're cheap for a reason because they don't have software people writing their software. They just that was probably enough of an NT or that. So now that we have the internet and computers, we have automatic time synchronization with NTP, which is mostly good. When we get to the bug section, we'll talk about that a little bit too. So,
What does that stand for?
network time protocol. It's one of the protocols. There were a few, but I think this is the one that most people use nowadays. Like, back in the late 90s, if you had a Novell server, Novell would do some special stuff when you logged in and set the clock on your workstation so that everybody agreed. And if you got Novell, the time screwed up on a Novell server, you would get something called synthetic time, which was difficult to get out of. And nobody has to worry about that anymore, so I won't bother you with that. One of the problems with NTP is inserting leap seconds. There's like 3 or 4 different theories on how to do that, and apparently they don't quite agree on that. So, because one of the ways you can do it is just have that second 60. So, but most computer programs aren't going to be happy about that. If you try and insert 11:59 to 60 seconds into your database, it might get upsetting. Another way is to slew the clock ahead of time. So stretch seconds for a few hours or a few days ahead of time so that you just don't notice. So that you're a little bit ahead, a little bit ahead, a little bit ahead, a little ahead, and then a little behind when the actual leap second occurs, and then eventually you're all good. And there's a few other strategies too. Nobody can agree how to remove leap seconds. So if there's ever a negative leap second, your computer might stop. Alright, that gets us closer to time bugs. So, as you can imagine, there's leap seconds which aren't that crucial. It's just 1 second. So, most of us aren't going to have to worry about that unless we're dealing with something that's really critical. So, the one thing is, for like my scenario, I can't hard code the offset into my GPS tracker because the offset will change occasionally. So, and actually I wouldn't do that anyways. I'd send time as I receive it and make it on the server side because I don't want to have to reflash a bunch of trackers and get them from the field. It's complicated. So, don't want to hard code it though because then leap seconds happen and then you gotta get up in the middle of the night and fix things. So, Zune 30 is one of the famous time bugs. So the Zune player was Microsoft's answer to the iPod, and round about December 31st, 2008, they all stopped working. They just locked up. Completely. Nothing you could do.
All 7 of them.
So all 7 of those kids who got Zunes for Christmas, not only were they really ticked because they didn't get iPods, they had broken not iPods. So what happened is, that was when I was actually 2 years old. So oh, that's a preview of cell phone. So it locked up on June 30, and what happened is Microsoft used the sample code they got from Freescale to run the chip that they put in the Zune 30. So they just used it without testing it and without caring if it worked, apparently. So after a lot of finger pointing and internet scuffles, the official fix was to just change the date to a different date, and that would work. And then once you pass June 30, you can change the date back. Lots of finger pointing. Toshiba did it too on their Gigabit S. So the Gigabit S also had the same problem. There was one user of that, and the user already never noticed. It ended up being Freescale's software that they provided for free with the chip. The eventual fix was just fudge the clock, which is probably fine for that thing.
Wasn't that the end of the Mayan? No, 2012 was the end of my Mayan calendar. I thought
That was so. What happened is there was 366 days in that year because it was a leap year, and that was too much for the software to deal with. So when you're testing for leap year, you have to test not only on February 29, but also on December 31st, just in case your software counts the number of days in the year. So if it's using like, I think they call it Julian date, which is the number of days since the first day of the year, and you're gonna blow up if there's 366 days, and then you probably wanna find that bug before your users do. And Excel has a bug. This one is interesting. Oh wait, it's Microsoft again. So, Excel, it's another leap year bug. Pretends that February 29, 1900 actually exists, and it doesn't. There is no February 29, 1900. Why did they do this? Because Lotus 123 did it. So Lotus 123 was the spreadsheet back for a few days in 1980 something. And then Microsoft says, ooh, they're making lots of money. Let's get our lawyers to make lots of money too. So they made a spreadsheet too. Ooh, if we make it work right, then our users will complain. So let's make it work wrong, so it's just like Lotus. So that's pretty much what they did. So it's not really a bug, it's an intentional feature.
Microsoft.
There you go.
Works.
Okay, Y2K, we've all heard about that. Okay. I may not mind Y2K. Let's just use 2 digits for the year. It'll save space. What could possibly go wrong? I was talking to my buddy Pete, who is older than dirt and worked in computers back when saving 2 bytes of space was a big deal. So they talked about it. They knew it was a real issue. They said, we'll fix it by then. Okay, so we'll rewrite the software. This software is never going to last that long. This was in the 60s and 70s. It was 30 years away. What could possibly go wrong? So they knew it was an impending issue. And not having the experience to know that if you say that you're going to retire the software by then, that's bringing down a curse upon you that you have to support the software forever. They said at least we'll be retired by then. And they're all happy about it, watching us squirming in their crap. So, why 2.038K? That's why 2038. That's coming up. And if you use a 32-bit integer to count the number of seconds between January 1st, 1970 and now, or we use that as your time base, epoch time, Unix epoch time. If you use a 32-bit integer, you'll run out of seconds in 2038. The exact date is January 19, 2038, if you're interested. So make sure to have enough money and retire before then, so they don't have to fix it. Or you can be like AOL, who learned early. in 2006, every single one of AOL's web servers crashed. They all crashed. Didn't work. Then people probably got fired. What happened? There was a config file, and somebody hard-coded a timeout of 1 billion seconds. It's a big number. We're never going to run out. It'll be fine. No worries. 1 billion seconds before 2038 is May 12th, 2006. That's when all the servers crashed because the timeout overflowed, so everything was timed out. So it blew past the 32-bit barrier. So every timestamp was bigger than 0, or negative. It was probably not signed in, so whatever. They had to fix it. They had to patch the config file on all their servers. I'm sure they didn't have all the cool tools we have today. Someone had to go around, patch reboot. That was probably a lot of fun. People got fired, and we didn't. This was 2006, 6 years after Y2K. We didn't learn the lesson from Y2K. I mean, really? So the cause was a 32-bit signed-in restoring time. Tips for dealing with date time. My slides are broken. I will not do a talk on slide SharePoint thing because I don't do it very well. Don't write your own parser. There's tons of parsers out there. Don't bother with trying to write your own because you'll screw it up. I won't write my own. I won't do my own date math. I'm going to use a library because then I can blame someone else when I screw up. Be careful with local time versus UTC time. Okay? Everybody seems to default to using local time, including me. So if you're a C# kind of guy, person, then datetime.now is how we get the time, and we're good. Until we expand to be multinational, and then we have to figure out, oh, are we storing South Bend time, or are we storing California time? Oh, we bought a company from Timbuktu, which is in a different time zone, and our databases are all, everybody's screwed up. Nobody knows what time it is. So my suggestion is start early, store everything in UTC time, and convert from there. Chances are you know where your user is, you know where your customer is, so that you can show them the right time. We have JavaScript libraries to deal with that stuff. So some of the libraries you might use, if you're using C++, you can use Boost. Java, you can use JotaTime. C# has pretty good stuff built in. For JavaScript, I kind of like moment.js. That also does things like this event occurred like 3 minutes ago, and it'll make nice user-friendly time stuff. There's a bug in a game I've been playing that I play with my kids. It's a trivia game. So one of us will start a game, and then it'll say this game was started 3 minutes from now, or so in the future. So they're not storing their time correctly, or my phone time is wrong. That's probably it. You should know how your time is being stored. So is your time being stored as a 32-bit int? If it is, you probably want to fix it quick before you retire or before too long. Otherwise, you still crash. When is the end of time? So 32-bit int, if you're using Unix epic time, and you got 32-bit int, 2038 is the end of the line for your time storage. Will it work until you retire? It's all, after you retire, you don't need to care. The guys from the 70s proved that to us. And how much precision and accuracy is needed? So, do you really need to store it down to 100th or a millisecond? The Java default is to store everything down to the milliseconds. I don't know if it's completely necessary, but that's their default. It's kind of neat because you get to see a lot of numbers and stuff. And when you're working on a system, you want to wrap the excess of the time from the system. So make yourself a little wrapper around time access. We're going to talk about that more on this slide. Yes. When you're testing time-related issues, stories, Rob remembers the first line clearly. Don't change the time on your server. If it's an NT server, it will get booted out of the domain.
Pleasure did that, didn't
Bad stuff, yep, will happen. People will be mad at you. It's not a good idea. And it's messy because then files get written before they are. Check for the leap year, February 29th and December 31st. Yeah, we actually had someone change the time on a server. It was a server that multiple people use. It was a QA server, not a production server, fortunately. But then, like lots of people learned his name. Check non-leap years. February, does February 29 work on that year? What will happen on leap second? Probably don't have to worry about it on the stuff that I work on, or is it too much? What happens with an invalid date? February 30, 2015. What happens if you put that into your system? Don't hard code dates in your tests unless you like fixing tests in January. January, the next year pops around, a bunch of tests break, you have to bump all the tests by a year and you don't have a problem until next year. So if you're doing like automated tests, don't hard code dates. Also, by not hard coding dates, it's going to shift around and you might, by chance, find a bug when your tests fail and you notice. Or if you don't notice that your tests are failing, you won't find it. But you might, it's happened on our team before, we found a bug because of weird stuff. Now, something we've been dealing with recently is a month. We haven't really covered a month in our discussions yet here tonight. So I'm going to ask, what is a month?
It sort of depends which meaning. According to where we go by, where I work, we have Reg Z. A Reg Z month for the Truth in Lending Act is from March 1st. Would be 1 month unit is from March 1st, April 1st, or from one date of 22nd to that preceding date. All months are considered equal in that amount.
Okay.
So never really defines it as 30 or 31 days. It says this many days from this point to this point.
Okay.
And it goes from this point to this point, and then you can count the number of days when you're trying to calculate the interest or do the amortization.
Okay, so you're working in banking. That's interesting. Cool. And they have regulations dictating how you calculate what a month is.
Well, they don't. They don't really. That's why we do business. There's one line in Regulation Z that was put in by the people who, like Joe Pitts, who started our company.
Okay.
And it says that all months are considered equal. And legally, by what that means is, you go from March 3rd you go from month A of date B to month Z, date Y. From 1 month to the next month, that is a month.
Okay.
But
So
nowadays,
from January 5th to March 5th is a month.
it's 2 months.
Oh, February.
Yes.
January 5th to February 5th is a month.
Yes. However, if you go from January 30th to February 29th on a leap year, that's also a month.
Okay, so what about January 31st? What's 1 month from January 31st?
February 28th or 29th.
Okay.
It depends on it also depends on how you're going to accrue the interest. There's different accrual methods. There's what's called actual days, which means we count every exact day and we calculate the interest across those days. Or there's what's called a standard Fed 30, or standard or 30 month day, which means that whole time period, even though you're going to go from January 31st to February 28th, you're still going to get 30 days of interest.
So you end up amortizing it across 360 days a year
instead of using 365, 366, we have 12 different time counting methods for that.
Cool.
I mean, that's
So when you're doing interest, You can either do it the actual days,
Yep,
in
that's,
case anybody doesn't hear, or you can do a 30-day month, which is every month is counted as 30 days. January has 30 days, February has 30 days, March has 30 days. So that's one way to solve what is a month. So when you're testing, you're going to have different rules based on.
we have never done exhaustive testing on things because there's so many different possible.
I don't want to. So he says never done exhaustive testing. This is an unknown person. Nobody knows where he works or anything like that.
It's Carl. So.
Hey,
Wait, what bank?
That's
No,
all
it's
right.
not a bank. What we do is we provide the DLLs that calculate out the interest accrued, principal, remaining balance, all the stuff that your bank, like if you got a mortgage or anything, or if you went to a car salesman or Chase or anybody, got a.
So you make the DLLs that everybody uses?
Yes.
What banks use your DLLs?
All of them.
Hold on, I gotta call my banker and tell him to take all my money out.
These were written in C. They're written in C. They were basically written for AS400s.
Not COBOL? Come on.
They were written before COBOL.
Okay, so you-
Well, I can't say that. They're written
Before COBOL, BC.
It's really cool. But the problem is that they were written they're written to be used on any server. So they can be used on Linux, they can be used anywhere, because we have, but like I said, AS400, so it's a whole file, which means there's all these compiler flags throughout the entire file.
Oh.
So it's very.
The problem is they were written to be used everywhere. It didn't make sense until you mentioned compiler flags throughout the file. You guys seen that? I'm so sorry.
Well, we don't know what to, I try to talk to them, what are we gonna do? How do we can't do it? Well, our customers are still using AS400, so we gotta keep this alive. And I said, well, why can't I take this, put it in a header file? Why can't I start modularizing on the code?
Yeah, that's a toughie. So, yeah, so I was getting to, what is a month? So, January 1st to February 1st is a month. January 15 to February 15 is a month. January 28 to February 28 is a month. January 29 to February 28, on a non-leap year, we're just going to say there's no leap years, is a month. January 30 to February 28 is a month. And January 31 to February 28 is a month, depending on who you ask. So that's one of the tricky things that I came with after I made this slide and before I got here today. It was just in the last week or two at work. We were saying, because the story said, look back 2 months. And it's like, well, what is 2 months? Because the scenario was we're doing file cleanup. So there's a shifting window of 2 months. So if we actually did that, the window would change size based on when the start was. So we ended up doing 8 weeks. So 8 times 7 days, and solve that problem that way. But if you do have to work with months, just watch out for that. So anytime someone says months, you cringe a little bit and say, we just do number of weeks instead.
Okay, so then you would agree that you would just calculate it based on 7 days for a week and then go back that many weeks to equal.
Yes, you fight with your BA until they give in. And use weeks instead of months.
Yeah.
Unless you're going to have them come up with rules. Our BA didn't want to come up with rules, and he didn't care. It was a cleanup story, so he gave in really quick. But he's really good otherwise. But in my suggestion, prefer weeks over months because of that kind of thing. John?
Oh, what I was going to say is that's another point about how you calculate out interest. There are 2 ways to count the days. You can count from this day forward, or you can do what the federal rule is, which is to count from the ending date backwards.
Okay.
And if you do that, in some cases you get 1 extra day, depending on how you do that.
Okay, so if we go from the ending date backwards, so there's 2 ways to do it, from this date forward or from the ending date backwards. So if we say, what was 1 month before, and this was the actual scenario, we're going backwards, March 28. Oh, it's easy, February 28. No.
March 31st.
March 31st, it was easy, February 31st, duh. So months around February get interesting, and we were, yeah, and if you go, yeah, it was kind of neat, but we told our VA, let's do so many weeks, and it worked perfect. So, what's the, talking about times and dates and everything, how should you write out the date? Do we have any volunteers to come write current date on the board? Rob, go ahead.
Sorry. I have a strong opinion about this.
Good. On the
We have a
use your blood.
teachers have been already all markers here. So today's what? April 16th?
Yep. I'm sorry, I don't know more than that actually works. We will describe it.
I should probably do this big enough for people to read.
I don't think it's helping.
It's still faint. So 2015, 04, 16, and then if you want to add time, you go from there.
So
from
year,
largest units of time to
month,
smallest.
day. How do
Because
most
this sorts
Americans?
better than anything else.
Yeah.
does.
Japanese, there's a Japanese date for it.
That's why I have a very strong feeling about this
How do
because
most Americans write it down?
unfortunately, we're right it is. And then we have the Y2K problem.
Europeans?
16.4.
What if it was April 4th? They just write 4/4.
Right.
Yeah. April 6th? How about June 4th? So, XKCD, I like these people, this guy. Public service announcement, write it this way. Get that URL. This is ISO something, de something, de something, de something. But there is a standard way to write the date, and the standard agrees with Rob. So Rob is correct. And don't write it in Roman numerals. Don't write it in whatever that is. No binary. Oh, okay. So I think I missed whatever. Whatever. Hit this URL and prepare to read comics for the rest of the day. No, he's funny. XKCD is pretty cool. So, fun facts. Watch crystals, like how many people have a watch on? At least one other person besides me. I'm not the only uber nerd in the room. You're not an uber nerd. Unless you want to be.
And then that's
Watch crystals are actually cut so that they're most accurate when you're wearing the watch. So when you're not wearing a watch, the whole entire thing cools down. And so the watch will either speed up or slow down depending on the temperature coefficient of the crystal you're using in your watch. So the more you wear your watch, the more accurate it's going to be. So wear it to bed, wear it in the shower, wear it at night, wear it all the time. Or just set it every couple of years when it's the second one. So I thought that was interesting. I read that one time. It was neat. But I have like several watches, so I can't wear them all. Bummer. I think my watch actually syncs up to my whatever other thing now. Metric time. This is where the French people come in again. Back in the 1790s, the French attempted to introduce metric time because metric is going to be the rule-all system of everywhere. To heck with those stupid inches and miles. Metric time is going to rule the world. You know, it didn't work. We're still having screwed up sexagesimal time, which is base 60 stuff. And again, in the 90s, Swatch took a go at it with their net time, which I think was a takeoff of the metric time anyways. And there's a trick you can use to tell a real Rolex from a fake. My dad is not the most luxurious person. He bought a fake Rolex from somebody. He knew it was a fake. Everybody knows it's fake. But there was a really easy way to tell the fake from the real one because his buddy had a real Rolex. So they look mostly the same. There's two ways you can tell, really. The fake Rolex kept good time. The real Rolex didn't. Some of the real Rolex got fiddled with it every once in a while and set the time. At least Mike's did, his buddies. Also, the fake Rolex looked better. It was more, the colors were brighter. The fake one looked faded out. But, so when you're going to buy that real Rolex, make sure it doesn't keep good time, otherwise it could be a fake. Alright, who's in charge of time? There's a place, the BIPM, which they're closely related to the EARS, and I don't have recollection of what BIPM stands for, but they're in charge of time. So it's an international group that is in charge of all these leap seconds. So there is a group in charge. They're the ones that make the leap seconds happen in coordination with the IEARS, which rotates the Earth. All right, this is a story that I came across while thinking about this. It was on NPR. The end of time as we know it. There's a group of college students that have made a clock so precise, it goes out to so many decimal places that if you move it from one place to another, it's not accurate anymore because of the relativity of time. So if you're in a spaceship going super fast, time isn't going to go the same speed as someone standing still. Okay? Now, this story made a big deal out of this. This clock, this is a picture of the clock. It uses lasers and rubidiums and juniniums and other scientific junk. Looks like a mess. But this isn't really anything new. Okay, we're going back to GPS land again. The GPS satellites, part of the way that GPS works is by the time difference between where you are and how fast the signals get to you and stuff like that. But the satellites are orbiting the Earth at a certain speed, and their clocks have to be very accurate. And that's part of why GPS has put out time, because one of the modern ways that you can synchronize time is from GPS time, and that's pretty accurate, depending on how accurate you want to be. It's good enough for some applications, many applications. But the GPS satellites have to lose 38 microseconds every day because they're going fast enough that because of relativity, if they didn't lose 38 microseconds every day, the position of the fix that you're given by your GPS would change by about 6 miles a day. So after one day, the position will be totally jumped. So they have to, their clocks are calibrated to lose time every day, 38 microseconds. So this, having a clock that is so accurate, yeah, it's kind of novel that we can do it on Earth, and moving it 10 feet is going to be changing the way it operates, like through relativistic stuff that these kids did way too much science to figure out. But it's been since they started doing the GPS satellites and stuff, like in the 70s, they've known about and had to deal with this. So it's interesting awareness and stuff. All right, what time is it now? It's time to go get beer, or whatever you guys do when you're done. So, any questions, comments, or anything about that? Rob?
My only add to this is there's a very interesting Stack Overflow post, and I think I sent it to you.
Just one?
Related to this particular topic, and it has to do with Microsoft SQL Server date times, and they have an issue where the .NET date time minimum is January 1st, year one, And the earliest date that SQL Server will take, though, as its datetime minimum, is 1/1. It's 1783 or 1793. And it
Okay.
has to do. It's a historically based issue that I believe it was 1783.
Yeah,
was
is that
the
when the Gregorian calendar started?
Yeah, it's the
Yeah.
first time, not when the Gregorian calendar started, but it was the first full year where the United Kingdom, or Great Britain, had adopted the Gregorian calendar. So for the Western world, at least, that was the beginning of a fully European accepted Gregorian time, and but it's very Western centric. Like Russia didn't accept Gregorian time until the 1900s, and it's apparently a holdover from a Sybase code base that Microsoft started with when they
Yeah.
I believe it was Sybase. It's a really, really well researched post. So I'm sure you guys can find it out there. But it was.
It just.
It always blew my mind because there were times where I tried to send in to a database datetime min in .NET, and this is before I knew about that, and it said you can't do that. The limit is 1783, and it's like that's really arbitrary. What does that have to do? I mean, and these are two Microsoft products. Why don't you agree on what datetime min is? Like, this doesn't make any sense to me. Why can't I just send that into the database? I believe the post goes on to explain that there's a datetime 2 that does accept .NET's datetime min, but for legacy reasons they can't change what datetime min means for that particular column type. But to get one of those kind of like the Lotus 1, 2, 3 pieces, that they started with it, it's been there, it's stuck, and if you want to use.
So it comes down to politics and
Well,
getting to
there are
corporate
dates
working
and
together and getting.
So this is a database issue?
mm-hmm.
And now that
SQL
we're
Server.
now that we're into cloud and we're into data scientists and we're into dissecting data for reporting, that's interesting.
But I mean, very few people are working with dates that are from pre-1800.
Right.
If for some reason you were trying to catalog that kind of stuff, your options would either be string, put things into a string and then parse it yourself, or one of the other options was the datetime 2, which I believe will take all the way back to year 1, if I remember correctly. So yeah, that accounts for a wider range of dates and everything. But it's interesting where legacy and talking about politics and stuff, it also had to do with, I believe that year prior to it starting, there was like a range of like 13 days that are just not dates in the Gregorian, like they didn't, their calendar didn't line up with the Gregorian calendar, and they would literally have like, well, this date span, is it 3 days or was it 15 days? How are we going to calculate that, because the rules got so complex at that point.
Yeah.
So.
Yeah. So I mean, yeah, going back to that kind of stuff, you're gonna find a lot of neat stuff and learn about history. It's a nice diversion from actually having to work every day.
Something else you might want to add into your talk about the history of the different issues is the issue of the year dates. In like the 1700s, I couldn't tell you exactly, but it had something to do with the difference between adopting the Gregorian calendar and when they started using January 1st as the first day of the year.
Okay.
So dates between January 1st and I believe it was the vernal equinox were called, say, 1738, 1739, or just 1738, 39, because you didn't know if it was the year before ending on March 20th or beginning on January 1st.
It used to be that the year didn't end until the equinox.
Right.
Then they decided to start the year over in January. Oh, that's kind of neat. Cool.
Run into that a lot in my genealogy research.
That's what I was thinking about
It's
when you
listed
were
as
saying
a,
the 1700s. I was thinking genealogy and ancestry might be interesting in that area. Like,
and of course, the other thing I come across often is the date year, or the day month or month date. We translated it over into common language. I just came across a record where there's 2 different birth dates listed. One was like June 4th, and the other one was April 6th. Okay, come on, let's get our act together.
Yeah.
Come on.
It's, June 4th, April 6th, just transposing those two, yeah. Yeah, I mean, if you sloppy like that, you never know. So, it's kinda neat. Cool, thanks for having me. John, did you have a comment?
Well, I have no question about the GPS. It's a signal that comes from the satellites, right? So is that jammable or?
Yes. So it's 1.8 or 1.5 gigahertz, and it's not too hard to jam those. That's for a strict GPS signal. A lot of units are also using like tower signal, so on the 800 megahertz band or 1.9 gigahertz band, so the towers can also get you, and you can jam that too, in much the same way. It is illegal because you're transmitting unlicensed transmissions on radio spectrum.
Well, I'm just wondering because aren't a lot of our drones GPS based navigation? I'd hate to think some guy out there with an induction coil in Afghanistan is hitting
You
the
don't-
circuit and jamming out the
Yeah.
drone.
It depends how you do it. That's an interesting concept, but you don't need GPS if you're going to do dead reckoning. So if you start out with GPS, you know where you are. You have an accelerometer and a gyro. You can keep track of where you are, what turns you've made, what's happened since the last known GPS, and keep track of where you are. And even some commercial, GPS like in your car, do exactly that. So that when you go under a bridge, some of them just guess. Mine just guesses. So it loses signal and I'm going in random directions. But some of them actually have a gyro and a accelerometer inside of them to keep track of where you're going. And that also helps to work with the GPS signal so that you can increase the resolution of your flights. And maybe even use it for GPS.
I had one other question. What about other calendars like the Chinese calendar? I mean, how is that structured versus the Gregorian calendar? Because I looked at that through, I think Google GCal has, you just let you go down to a Chinese calendar, but I've never really,
Yeah.
I mean, it's just the same as us with 7-day weeks, or, because I know they're lunar based instead of solar based.
Yeah, I never really thought about that, so you're not gonna be bored tomorrow at work. No, that didn't come into play, so I don't have any information about that. I apologize.
That's okay.
But yeah, it's it'll be something interesting to come across if I ever get. Thus far, I haven't had to. So
What about dates before Christ?
okay, so BC for Christ. We don't get into that too much at work either. But again, once you cross that 1700 barrier with the calendar goofiness, you're gonna have weird stuff. So I guess it depends on why you care, like, why you're concerned about that, as far as what you're gonna do about it. Do you have a specific scenario?
No.
I'm just curious.
Yeah.
I never run into it either, so I'm kind of like, don't have a good answer. But you can map the current calendar to that, or otherwise you can do some research and find out what historically happened. Because there's a lot of, like there's months that didn't used to exist, like August and September are months that they didn't used to have. They came from Augustus and Septavius. And when they needed more months, because when the calendar first developed, they had a very simple idea of how it was going to be, and they used 10 months. And then there were 10 equally sized months, I think maybe 30 days, I don't know. But then they had to insert months. Augustus was a big shot back then, so he had his own month. And Septavius, I guess, was also a big shot. He got a month. So, okay, maybe my information is slightly wrong because there's a lot of people getting their own months.
Just for strict year calculations, going back to BC, the most important thing to remember is there was no year zero.
Okay, yeah.
If you're counting days, you gotta remember that 10 years, or excuse me, 10 days were omitted, again, can't be authoritative on what year or which pope instituted it, but it's catch up Gregorian calendar up with the heliocentric year.
Okay.
Well,
So,
why do centuries start, like the 20th century is the 1900s, and the 19th is the 1800s? And why is that? Is that because the year zero?
Because the first
Well,
century
yeah,
started with the year
so
one.
First century was year 1 through 99. Yeah, I thought about that. I forgot my power pack, so my screen keeps turning on. Sorry about that.
How precise is the GPS time? To what dimension? That's the microseconds or nanoseconds?
It depends on it depends on your receiver. You buy a more expensive receiver and get more precision. But then, if you need to go further than that, you get you get one that does the GPS, and you get one, and it also does like the radio time. And they use that radio time to sync up between the Boulder time and the Hawaii time, and the Boulder time and the Paris time. That's how all the different international agencies sync up, is with their radio signals. So that is really quite accurate. So if you need a standard second, you can use the Colorado time. And it depends on how precise you need to be as to how much money you're going to spend getting. Like, one thing is like a 911 call center. They have to have fairly accurate time, so they have a fairly expensive box to synchronize the time on their call recorder, stuff like that. And I had a buddy that used to do calibrations of things, and they had a GPS box to calibrate time. So they're pretty good, depending on what you need to do with it. Interesting to see something that it wasn't good enough for.
Is there a maximum limit to which precise you can get from the GPS?
Yes, I would imagine. I'm not sure what it is.
I had a question about measuring time. When you're measuring a clock cycle inside of, I'm not sure about what it is now, because now I just go out and buy a computer, start building my own, but used to be, used to overclock. So you drill out the crystal, or you drill out part of the chip where you knew they were taking the time base from. How do the CPU clocks in general do the time syncing now? Is it there's still a crystal somewhere that's putting out so many hertz, or
I believe nowadays the clock is actually on board the CPU.
clocks on board?
It's providing its own timing, as opposed to 20 years ago when you had a separate crystal controlling the timing of the whole bus.
Yeah, that's
So there's still crystals on the board, but there's also, you got NTP to sync your time, and then the clock within the CPU is PLL synthesized from the crystal, and then for the CPU speed, the actual speed the CPU is running doesn't matter too much against like real time, because you're going to synchronize against NTP. And then one of the things that you can configure in Linux in NTP config is you can, I don't know if you can configure it, but you can see the correction factor that NTP is using against your computer clock, which when you boot up your computer and it's cold, that's going to be different than when you have your computer running. But that comes to like how they cut watch crystals, and the computer crystals the same way. As it gets colder and warms up, the frequency is going to drift slightly. They also have like temperature compensated crystal oscillators, TXCOs, which they have a thermometer inside the crystal that measures the temperature of the crystal, so it can compensate against the temperature of the crystal and give you a more accurate time base. But those aren't even that expensive. So your computers I think used to use those with modems and stuff, because if your modem's going really fast and modems go really slow, your connection's scrambled.
One other quick question. You said something about this leap second being sent out. Well, if I wanted to be, suppose not me, but hypothetically somebody malicious was out there, couldn't somebody malicious just send out the leap second? spoof to ask whoever, and then you guys sync up, and you just keep adding 1 second to everybody?
Yeah,
Eventually
it's not really
crash.
sent out, it's an FTP site, so they would hack the FTP site and insert extra bulletins, but,
I mean, if it's all, if the computer, if it's all XML based or some kind of just computer talk.
it's not XML, it's just text file.
But they give
so
you a
then
lot
parse
of,
it out.
they give you a lot of notice though, right? It wouldn't take effect for months.
Yes, but, see, that's one of the things with the NTP server, the way they synchronize, you don't get enough notice to deal with it, cause sometimes, the synchronization period isn't often enough to deal with it. But yes, the usual IEARS, Earth Rotation Service bulletins, are months ahead of time. Because this one was out in February when we got snowed out, and so it's all going to happen in June. But typically they know ahead quite a bit. The Earth doesn't do rapid slowdowns usually.
Does anybody have NTP?
That's really kind of funny.
Sending out
There we go.
an
I'm sure
offset.
there probably is. It's all UDP, and so you can do. Actually, NTP works both ways, UDP or TCP. But
That's when time servers go down next week, blame that guy.
No, I'm just wondering, because we've been having, for some reason, we've been having a lot of attacks from outside, like
Okay.
China, Budapest.
One of the things that is part of the NTP protocol is you reject a time difference if it's greater than a certain amount. So,
So slow and steady pack is your best bet.
right, you'd have, yeah, exactly. So you'd have to slowly drift it, and one of the ways they counteract that is NTP is usually set up for a pool server. So you go like us.ntp.org, which rotates along a pool. First of all, that distributes the traffic across all the people who have volunteered to be NTP servers. And within the protocol, you can find out what stratum you are. That means how far away you are from a real standard. But also that makes it harder because you're hitting us.ntp.org, which is going to change this IP address every once in a while. So you would first, ideally, hack the DNS that the people are asking, then you can always give the same response, which would be your fake NTP server. And why are we talking about all this hacking stuff?
Well, if you control the network, just man in the middle or something. Redirect.
You're trying to anti-hack. You're trying to get some security.
Yeah, exactly.
Yeah, that's cool.
That's a good thing.
But yeah, NTP is, it's not perfect. Everything's manageable, hackable, whatever. So, but it seems to be pretty robust. It seems, and what you probably can do is have, if you're quite concerned about, have two servers. One that looks at the outside world, because a good way to do your NTP setup within your network is to have a server that synchronizes to the outside world, and all your internal stuff synchronizes to that server. And then you could have another server that has a fairly good clock that compares to your external synchronizing clock and raises bells and whistles if it's ever been changed significantly, or it can also synchronize to external ones, compare the time of your internal one to kind of have a secondary
Checks
way.
and balances sort of thing.
What's that?
Checks and balances sort
Yeah,
of
checks and balances, exactly. So, yeah. Anybody else? What do you guys usually do when we're done here?
One